Happy Monday! Let's continue our fraction learning with a problem that is similar to the problems you were working on Thursday and Friday. So Calvin biked 1/6 of the 24-mile trail. How many miles did he ride? First thing I want you to do is write an equation for that. You should definitely pay attention anytime the word of is used in a math problem. 1/6 of 24 really means 1/6 times 24. Okay, so let's see. Let's think about how big our answer is going to be. Is our answer going to be more or less than 24? Hopefully you said less, because 1/6 is just part of the distance, right? Just part of it. So part of a whole. Is it going to be more or less than 12? More or less than 12. And 12 is half of 24, right? So is 1/6 more or less than 1/2? It's smaller. That's right, it's smaller. So therefore, our answer is going to be smaller than 12. Okay, so that's just good to think about. Now, when it comes to using our fraction bars, we did this already for a couple of days, but I'm going to do it for you here. If the whole fraction bar is 24 miles, okay, so the whole in this case is 24 miles, and Calvin biked 1/6 of it, then we need to sort of visualize what 1/6 looks like. So the way I do sixths is I divide the bar in half, and then I'm going to divide the half into 3 equal parts, because I know that sixths are half of thirds. Okay, so there are my sixths. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So if he only biked 1/6, then we're saying he went this far, if this was the start and this was the finish. So how do we figure out what 1/6 is of 24? Well, some of you were thinking, and I think it's a really good way to solve this, is if this is the whole and this is 1/6 of that, then we know that this plus this plus this plus this plus this plus this has to equal 24. So if we take the denominator and we divide it into 24, or 24 divided by 6, we get 4. So that means each sixth is worth 4 of those miles. Can't see this one very well, but I will put it over here. So 4 miles. And just to double check, what is 4 times 6? 24. So we know that's right. So 1/6 of 24 is 4 miles. Okay? So that hopefully jogs your memory about what we were already working on. Now let's go to our next lesson, which is multiplying a mixed number by a whole number. So let's try a little bit of an easier one first, okay? Calvin, same guy. Calvin rode 1.5 times around the trail. The trail is 24 miles. How many miles did Calvin bike? So when I'm thinking about the trail, if this is the trail like that, and one time around it is equaling 24 miles, well, he rode one time and then half. So half of 24, you probably guessed, is 12. So one time would be 24 and half would be 12, right? So let's see how we represent that on a fraction bar. Is your answer going to be more or less than 24? More or less than 24? Hopefully you said it's going to be more than 24, because one whole would be 24 miles. If he does a half of that more, then it's definitely going to be more than 24. So in order to represent this on your fraction bar, we need to show that this here is 24 miles, and he goes that whole entire distance, right? So this should be all shaded in, so that's 24 miles. And then he goes further than one whole, so we need to jump to the second fraction bar for this. And he goes half of 24. So this here again is 24 miles, and he goes half of the 24. Boop, like that. So, as you guys are probably screaming right now, yes, half of 24 is 12 miles. So he goes 24 miles plus 12 miles. So that is a total of 36 miles that Calvin rides on that day. So 36 miles. Ooh, we forgot our equation. Did anybody scream that out? Oh, we forgot our equation. It would be 1.5 times, yes, 24 equals 36 miles. Cool, 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 cool. Okay, let's try one that's not as easy, but certainly not too hard. Alrighty, here is our next question. Calvin biked 3/8 times, 3 3/8 times around the 24-mile trail. How many miles did he ride? So let's go to the equation first. 1 3/8 times 24 is our equation. Again, the whole is 24 miles. Hopefully you can see that, yeah, we're going to have to go on to another fraction bar to represent the 3/8, okay? So is your answer going to be more or less than one whole? More or less than 24? Yes, more, because one whole would be 24, but we're also going to ride 3/8 of the way around the trail again. So in this case, this fraction bar is completely filled in. He rides one whole distance, so 24 miles. And then the 3/8 part, how do we represent that on here? Well, we can see that we need to divide this fraction bar up into 8 equal pieces to show eighths. The way that I do that is I half the fraction bar, and then I half the halves. So now we have fourths. And then I half the halves. Wait, do I half the halves? I have halves. Yeah, one of those. You know what I'm saying. Yes, I half. Oh my gosh, never mind. So anyway, here are my eighths, and they're pretty equal. Not perfect, but hey. And there are 8 pieces here, and he rides 3/8 of those. So this amount here. Okay, so the work is not over, however, because we need to figure out how much is 3/8 of 24. So if this whole thing is 24, what number is added up all together 8 times to equal 24? Or what number times 8 equals 24? And I can hear you screaming right now. Yes, it is 3. 3, 3, 3, 3, 3, 3, 3, 3. And just to check, 3 times 8 is 24. So if we multiplied that or added them all together, we get 24. And then Calvin, he bikes 3/8. This is 1/8, another 1/8, and another 1/8. So all together, 3, 6, 9, that is 9 miles out of the 24. And that is equivalent to 3/8. So when we need to figure out, well, how many miles is 1 3/8, we add the 24 miles from the 1 hole and the 9 miles from the 3/8, and that will tell us how many total miles Calvin rode. So 33 miles is your answer to that one. What do you guys think? Easy peasy? You got this? Awesome. So today you are going to be working in your packet, and the page numbers are, let's see, page numbers 433 and to the end of that packet. So pages 433, 34, 435, which is some ordering decimals practice. Please use a really, really, really sharp pencil, Ella, on this one, because it's hard to fit all of those in. And then lastly, 436, okay? Now, if you have already gone through these pages, I want you guys to double check your work. I want you to have watched this lesson, to go back and make sure that you have illustrated your fraction bars the same way, okay? And that you've written an equation for each one. So I'm going to leave some extra fraction bars here on top of the projector for you to take at your leisure. I know some of the problems say solve each problem. For problems 3 through 5, use fraction bars to represent the problem and write an equation. So really what that means is if you don't need to, like you can already solve the problem without a fraction bar, then you don't need to use one for numbers 1, 2, and 3 on page 433. However, for problems 3 through 5, you do need to show your work on a fraction bar. And then same goes for the remainder of the pages. Please read the instructions completely so you do the work that is required. Okay? All right. When you finish this, I have some what do you call it? Fraction work, like adding and subtracting fractions with different denominators where you have to borrow and carry, and then also some coordinate graphing fun stuff for you guys to work on. So that would be the order of operations here. Do the multiplication of fractions packet, finish that, then you can work on the, what do you call that? Oh my gosh, the adding and subtracting of fractions. So just kind of going back and reviewing the work that we've already done a few weeks ago. And then when you do that, you have the rest of the time to be doing the coordinate graphing. And there are two levels. There is one level, which means only working with the first quadrant. And then there's a 4 level, which is working with all 4 quadrants. Sound good? All right. Thanks, guys. I miss you.